learning. Ladies and gentlemen, please welcome Nur Afiqah Aling Elias Muhammad.
Infertility, or the inability to have children, has caused many women and families in great despair. I'm sure that you know at least one person who has a problem conceiving and has tried countless ways and spent huge sum of money just to be able to carry a baby of their own. But did you know that a leading cause of infertility can actually come from a disease? Polycystic ovary syndrome, or PCOS for short, is a problem in which a woman's hormones are imbalanced. It causes the growth of many small cysts in the ovaries. This syndrome is affecting 7 million women to be infertile. Can you imagine? 7 million women who have difficulties bearing a child just due to this disease alone? What's even more disheartening for these affected women is that if PCOS is detected late, they'll have an increased risk to develop other chronic diseases, including diabetes, high blood pressure, heart disease, and even cancer. One reason why PCOS is so difficult to be detected early is because there is a complex varieties of symptoms and no single characteristic can tell you if you have PCOS. These complexities come from different proteins in our body, but how these proteins interact still remains a mystery until today. Knowing the interactions between proteins will help us to detect PCOS better and earlier. In our study, we use a computerized method called protein network approach to identify how PCOS can occur in our body. Protein network is the interactions of proteins or how they communicate to each other to perform various functions in our body. For examples, how the proteins interact to respond and correct a damaged tissue. We compile all the PCOS-related proteins that have been previously studied and depicted them into a protein network. Then, we merge this network with the biological processes and past medical records of PCOS patients. As a result, we can see how the proteins interact, what and how body functions have been disrupted to cause PCOS. Not only that, we now know how PCOS can be linked to other diseases by knowing which proteins are responsible and how they communicate. These valuable data will then be used to develop an easy yet accurate diagnostic kit that has a huge potential to save the lives of many women and realize their dreams of having a baby of their own. Thank you.
Thank you, Nur Afiqah Aling Elias Muhammad, for that informative talk on PCOS. And Nur Afiqah is from Institute of System Biology INBIOSIS. Her PhD work is on construction of protein-protein interaction network to understand the pathogenesis of polycystic ovarian syndrome, or what we normally know as PCOS. Her supervisor is Associate Professor Dr. Zeti Azura Muhammad Hussein from Institute of System Biology INBIOSIS, and her field of expertise is on development and application of computational methods in big data analysis and PCOS, or polycystic ovarian syndrome. And I hope one day, Afiqah, you will find a cure, because I am one of those who actually suffered from PCOS, and that has caused me infertility for 5 years before I actually have my first daughter.
There was a pretty princess who fell into deep sleep because of a curse. This lovely fairy tale should have ended when she is awakened by the kiss from her true love. However, there is an untold part of this story, and I'm here today to tell you that this beautiful princess actually has an allergic disease. There are little tiny creatures under her bed, able to wake her up every night, causing her to sneeze, have running blocked nose, itchy eyes, and skin. No worries, our dear princess is not alone. There are over 300 million people in the world tortured by these same problems. And according to our research in Malaysia, 90% of these allergic people have the problem with it. And 1 in 10 children will have asthma. So, who is that? It is called house dust mite. As their name suggested, they are found in the dust in your home especially on the bed, where you spend 8 hours a day sleeping on and breathing in their droppings. Luckily, dust mites don't bite people. We feed them constantly with skin flakes that drop off from our bodies all day long. Skin flakes are hard to be digested, so dust mites have powerful enzymes in their body that can digest skin flakes. And finally, all these skin flakes will turn out in dust mite poop. Ladies and gentlemen, let me just say that you do not want to know how many dust mite poop is there in your home right now. When people breathe in dust, they breathe in the poop and the enzymes too, which in turn can irritate the lung and aggravate asthma symptoms. And previous research work has shown that dust mite proteins is the reason why people have allergic disease. So, this is now we, as a researcher, come into play. We can determine the 3D structure of proteins and let it tell us some hidden story as well. So how we did that? We first caught dust mite, pull out all the proteins from it. After identifying the most important protein, we then crystallize it. By shooting X-ray on crystal, magically help us to know how it looked like and how it causes allergic disease in humans. Soon after, our research work can lead us to design an effective vaccine and drugs that can cure princess and dust mite allergic peoples all over the world. So every dust mite allergic peoples can then have deep sleep at night time, be free from asthma, running or blocked nose. Finally, princess can free from dust mite problems too. And princess and prince can live happily ever after. Thank you.
Thank you, Afiqah Sze Lei. The Princess Aurora sleeping was actually a good sight to see, but the dust mite is certainly not. It was a scary thing to see when it was just a big thing like that. So Afiqah Sze Lei's work, her PhD work, is on structural and allergenicity studies of group 21 allergens from house dust mites. And she's being supervised by Dr. Ng Chian Leong and Associate Professor Dr. Chew Fook Tim. And Dr. Ng's field of expertise is on epitope analysis. It's a very long one, I'll read it. Epitope analysis of house dust mite allergen proteins, functional studies of human uncharacterized proteins that may be involved in polycystic ovarian syndrome, structural determination of plant sesquiterpene synthesis and alcohol dehydrogenase, structural and functional studies of hypothetical protein from pathogenic bacteria, Burkholderia, Pseudomallei, and gamma butyrolactone receptor that involve in tyrosine antibiotic biosynthesis, while Associate Professor Dr. Chew's field of expertise is on allergens and hypersensitivity, molecular immunology and molecular mimicry, aerobiology, epidemiology and genetic of asthma and atopy, hypoallergenic vaccines, autoallergens and panallergens.